Right, this could end up a bit of a long-winded video, but I'm going to do a few tests on the Lasersaber SJR Looper. This is my version of the circuit though, so this is for coils that don't have a central bolt in the middle, and these are the actual connections that are used, and some are different to Lasersabers. Interestingly enough, what I worked out was that what I'm doing is I'm connecting the end of the green to the start of the blue, so the end of the inside wire to the start of the outside wire, and then we've got the red in the middle with the large resistance that seems to be causing the long running effects. But that's the sort of thing I'm looking at today. What I'm going to be using are these three 3300 UF capacitors, which came from a board, PC board from 1997, somewhere like that, so I very much doubt they've got the capacity shown. There's also 1000 UF on the board itself that I would normally use for testing, and this board is something I've come up with the 4 germanium diodes at the top. I've got a quite hastily wound coil here for first tests. Here's the power input at the bottom, there's the output to the LEDs, the 5 in parallel, and at the back we've got a transistor, and I'll be using an LED for tests, another coil here so it's better wound, and a few different transistors to see if there's any different running effects. For this test I've put an LED across the red wires, that's the middle large amount of turns winding, and I've put it backwards to see if there's any back collapse. So from the top red here we've got the negative of the LED rather than the positive, and connected to this line we connect up the positive of the LED, and we'll see if there's if it lights up. And there we go, there is indeed a back collapse from that coil. Okay, for this test we're looking at the LEDs. Not only do they fade off quickly, but very often you'll get, there we are, a flickering effect. See the flickering going off there, and that seems to be a trait of a badly wound coil. And this one here has got no copper on the insides, and it's got a very hastily wound outer set of turns, and you can see the effects that happen with such a badly made coil. So there we go, that seems to be one of the traits. Now what I've done is I've put the LED across the emitter and the base, which is similar to our Slayer exciter. You can see the feedback, and let's just see whether we do get any light from that LED. So power up the circuit, and no, there's no light going from there, so that hopefully means that no damaging high voltage is going through this S9014. Now this is a much better built coil, and you can see that it's running along quite nicely now. So and of course it doesn't flicker either. So that's just the difference that you'll get from a better made coil. Right, someone suggested I do a microwave test as a Faraday cage, and I've always wondered myself actually whether they do blank out radio properly. So here is a microwave switched off, and there's my Xevious cab in the background. That's going to be a summer project. But anyway, let's see. So Mr. Art Bell on Old Coast to Coast. Let's see. That's a good sign. Yep, seems to block that out. Okay, so what I'm going to do is a test with this first circuit that I made, and still using the same battery there, and actually see whether we can see anything in there. Right, we'll get this charged up and we'll see what it gives. Give it a few seconds to charge up. Okay. Oh, we can see in there. Good. I'll leave this going then now. Yeah, it's coming out quite well actually on the screen, I'm surprised. I'll just sit here and wait now. Yes, it's always interested me, this Faraday cage business, and I thought I'd have to put extra extra metal shielding around or something, but seems to do a good job. Well, they're still going, but they are fading. Of course, it's not an optimal coil, so there's a lot of work to be done, but it's quite fun doing this kind of experiment. So probably not that good a run actually, looking at it. They're still on, I can see them with the naked eye easy enough. They'll probably sit like that for quite a while, but they're kind of pretty much disappeared from this smoked screen that looking through. Oh, okay, well, at least there it was running. We'll see if we can see them on actually. There, you see what I mean, they're still on, but difficult to see through the smoke glass there. I might as well leave them running now. But yes, difficult to see on the lower ends of the circuit running through a smoke screen, and that's what most of these microwaves have got. So that's perhaps an interesting pointer. Although of course we are looking for bright lights. Well, it's probably sit like that for ages now. Anyway, so that's the microwave idea. Here's something else I thought I'd try. Well, I've got a 1K resistor over this 3300 UF capacitor and an LED, and I thought I'd try that rubbish coil over the middle coil winding, and that actually works very well indeed. And I guess really in summary that these circuits have got a heck of a lot of potential for running for long times, but obviously I need to improve my windings, and will hopefully have better luck with one of those actual coils that Lasersaber uses. And of course my changes just enable different coils to be used, and they're not the same. It's not the same thing of course as Lasersaber's demonstration, but it does allow those other coils to be tried out, and you learn a lot about these kind of circuits, at least I have. So yeah, these are still going, and these are the kind of markers really, and if I can get longer runs than simply putting a resistor across or a coil winding, then we'll be motoring then. So there we go. Okay, thanks for watching.